Okay, we're going to do one linear programming question, and I gave them kind of the background for this, so I'm just going to jump right into the problem. We're going to let x equal mangoes and y equal bananas. Let's say that you are going to start a farm. It may seem like how could I start a farm? You actually can. There's people that start farms all the time. They usually don't. A lot of times they'll start with something like trees. They can plant trees, or even better, take an existing farm because it's already the trees are already there, and all you have to do is the nuts are going to be like falling off the tree. I got a chance to see a macadamia on that farm in Hawaii, and that was actually, she had bought it for, I don't know, like $100,000 or $200,000 or something. She had her husband had died, and she got a life insurance policy proceeds from that. And so she's like, you know what? I'm sick of New York. I'm gonna go move to Hawaii and take 200 grand. She bought this little farm. It has a little tiny house on it, so she lives on a farm in Hawaii now. What a change in life, huh? Go from New York in the city to be a nut farmer in Hawaii. But she has great weather. She's got a little dog that she, runs out and barks at you when you drive up, and she gets tourists come up and buy nuts from her and stuff. It was a cool thing for her. So anyway, in Costa Rica, I saw banana farms and mangoes all over the place. So I thought I'd show you an example of how you could do this linear programming thing for this. So on your graph paper, you're going to be making a graph for me, and I'm going to use nice round numbers just because it makes it way easier to graph. Okay, and let's say that we want to be diversified. Mango trees take up a lot of space. They're fairly big, and the banana trees are really small, actually. So factor that in when I say these things. We want to have some banana trees, so we're going to say at least 2 banana trees. I just did that wrong. Sorry. 20. Just to slap a 0 on it. 20 banana trees. And at least 2 mango trees, because they're really big, and so that's kind of the small end of things. On the big end of things, let's say that we don't have enough room to just plant unlimited trees, so we're going to say that we have 40 total trees is the most we can hold on our property. Did I just read you an equation? Better write these equations down. You're missing some of these. I gave you 3 equations now. Don't type them in the calculator, just write them on the paper. Okay. What was just to review quick, somebody's asking for a review. How many mango trees at most, or at least? At least 2 mangoes. How many banana trees at least? At least 20, okay. And then the total number of trees, 40. Okay. Now, common sense wise, can you have negative mango trees? No. Can you have negative banana trees? No. So then all of those things should be able to make you a feasible region. Now, generally rough sketching, just rough sketching here. When you shade to this side of this one and this side of this one and that side of that one, you're going to get yourself a triangle. I'd like to see if you can figure out what these 3 important points are. And then put them into this function. Let's say that a typical banana tree makes the person $1,000. Typical mango tree makes the person $5,000. Maybe there's other complicating factors like, yeah, but it's way harder to harvest mangoes because they're really tall trees and other things, but then the mango trees are way bigger, so they take a lot more water. But we'll just keep it simple for right now. The profit function is going to involve, this is what the profit you'll make off a mango tree, and here's the profit that you'll make off a banana tree. And I do know, for instance, there's a lot of almond trees being grown in California. So many that a lot of Californians are really getting ticked because the price of water for them has gone up a lot, and a lot of them are blaming it on the almond tree farmers. And apparently other crops too, maybe alfalfa. I haven't heard that one, but I believe you. There's some places that there's some crops that need a lot of water, and California's price on water has gone up a lot because they say those darn almond farmers are using it all up, and there's probably an argument for that. So they'll have to try to figure out how to make it fair. Like maybe you can't just like, even though you have a river running right past your property, maybe you just can't siphon off a ton of it for yourself for your almond trees. Maybe you have to pay for that somehow. Anyway. All right. Did you get X had to be greater than or equal to 2, and Y had to be greater than or equal to 20. You with me so far? How about that one that was a combo? What was that equation? 40, right? Okay. X plus Y less than or equal to 40. Now, at this spot right here, what you really need to know is what are the two equations that are crossing there? Well, this one, let me do color code them. This red one here, that's the red one. This green one here, that would be X is greater than or equal to 2. I'll make that this green one. And I'll make this black one here, Y greater than or equal to 20. We'll make that this black one here. The color coding does help. You won't be able to do that on the test very well unless you bring multiple colors of ink. You can actually. Some kids do that. So then I got to see where the green one and the red one intersect. That's right here. That means the red one, which is right here, and the green one, which is right there, X equals 2. Why did I chop out the greater than? Because all I care is where they cross. To do that, I can just say equals. That and that go together. Can't you just stick that number in your brain, though? I mean, I know you could put it in the calculator, but couldn't you just use your head and say X is 2, so stick a 2 here. 2 plus what makes 40? 38. Therefore, Y must be 38, and X must be what? 2, and that's a point, isn't it? 2 comma 38. I know some people like to use the calculator. Let me show you how you could use the calculator on this one. You'd need to solve this for Y, and you'd have Y is equal to negative X plus 40. Everybody, please put that in your calculator. I do want to show you how you could use the calculator for this. Y is equal to negative X plus 40. Negative, make sure you use the negative key, not the minus key. X plus 40. And delete off the last couple things I didn't need there. Okay. Arrow down, clear that equation out. And then, if I go to graph, I've got just one line. How am I supposed to put in, oh, I didn't graph it. I'm going to go to my window and figure out what's wrong here. Oh, it doesn't go up high enough. I need to get out to like 50 or 60. Remember on this, make sure it's big enough. Too big is usually not the problem. So I'm going to go big or go home here. Make it 60 to 60. Not 90. 60. Probably would have worked fine to use 90 there, but I'm going to try graphing it again. Aha! There's my line. How am I supposed to get the line X equals? You can't get a line X equals. But, and I've never showed you this trick before, a kid last hour showed me this. I knew about a different way to do it, but I never knew this way. Let me show you how I can figure out where X equals. What do I want X equal to equal? I look back at my picture here. X is equal to 2. All I have to do is hit the trace button and then type a 2. And you get how it instantly pops up X equals 2? Isn't that cool? Hit trace and then a 2. Now I hit enter, and it's as if they put a line in there and it sees where the two lines cross. And the answer was 2 comma 38. We did it with our brain. Now we verified it with the calculator. 2 comma 38 is one of the corners of my feasible region. Okay, so we got this one right here, 2 comma 38. It's good. Now find the other two places that things cross. You can do it by hand with algebra, like I did inside this box here. Write the two equations out, stick one in the other, or you can graph both of them and see where they cross. Find the other two spots. I'll pause for a second while you give that a try. Okay, let's see how you did. This kind, where the lines are straight up and down and across, is super easy. It's just got to be an x comma a y. So the x is the green one. X is 2. And the y, well, the y is the black one. And y is 20. 2 comma 20. Raise your hand if you had that one right. Okay. Then the last point is this point. Can you tell me what the two equations are that go across right there? The red one and the black one. So
X plus Y equals 40.
And the other one?
X, negative X.
Nope, it's simpler than that. So the black one here is the other equation. It's straight across line at y equals what? It's right there. See? Y equals 20. You know what? It's kind of irrelevant. It's y equals 20. I used to be green. I wrote over it in black, but either way, do you get this is a straight line and therefore it has to just be y equals blah, like a number? Y equals 20. There we go. Those are your two equations. Stick the one number in the other. Y equals 20 goes right there. If that's 20, what's x got to be? 20. So that's the point. What is x? 20. What is y? 20. And yes, you could subtract 20 from both sides, but you can just tell that x would have to be 20. Okay. So 20 comma 20. Now, what makes them the most profit? 2020, 220, or 338? It might be a surprising answer. This one seems like it's got so many. It's got 38 of this one tree that it might be pretty good. But Y's are the things you don't make that much money on. Remember how Y is the bananas, which makes you only $1,000 a tree? So this 2020 turns out to be way bigger. Comes out to 120,000. All right. Is that a reasonable income for a farmer? Yeah, actually, that's believable. A farmer in a good year can make even in Minnesota. Some farmers in a good year will make like $500,000 in a good year. But then again, what if the next year is bad? Farmers, you might think of it as, well, they've got a crop, they're going to make money. Nope. Actually, some years they make zero or even they lose money. They work all year and then they don't make anything. Why could that happen? Because you could have a bad crop. Like they work all year, but then it gets flooded out. Or they work all year, but the profit is so bad, like the price. Corn is notorious for like, sometimes it could be only selling for $4 a bushel. Sometimes it's for like $12 a bushel, and it can be so much more money in some years than others that some years they actually, when the prices are really low, they actually make negative money. They have all this corn, which they sell, but their expenses were so much that they make no money. Yes? Mm-hmm. Gotcha. So the story was that basically grandfather had made good money for like 10, 15 years, but the last 5 years made zero. So you can imagine, even if you had made good money for a long time, if you go 5 years in a row with no money coming in, that's tough. Even if you know, because maybe you got kind of used to, you're thinking, I'm going to probably make money this year. Nope. And then again, nope. And again, nope. It can be. So that's a tough job. The farmers oftentimes are like just scared of the weather. And you are right that there's farmers insurance they can buy, and most farmers do it because they can make sure that they won't have that $0 a year by buying the crop insurance. So if they get flooded out, they'll still get money from the insurance company because they get paid for, you know, like any insurance, a bad thing happens, you get paid. Farmers still have to pay for it, but they definitely make it, the government makes the price on insurance way cheaper than it would be because the government helps out with it. You're right. So the way I understand it, most farmers, it's such a subsidized, most farmers buy the insurance because the government makes the insurance cheaper than it should be. So it's actually a good deal to buy the insurance. So pretty much everybody buys the insurance. So, but they still, what's worse for them is if the price is really low, because you can't really control that. Government can't like make the price of corn be high. If the price of corn is really low, they can actually buy an insurance product again to guarantee you that some of the farmers will sell on futures, it's called. They'll sell their corn before they even have it. It's kind of a weird concept. They promise to deliver like 10,000 bushels of corn to so-and-so for this much money. And then if the price goes down a lot, they still got their price locked in. But if the price goes up a lot, they already locked in at the lower price. So it's kind of a gamble. Yes? I've heard that. And that's an interesting one, buying futures on political candidates. So they can actually sell you, like basically what you're buying is, if they think Barack Obama, is that even an option on the insurance market? I don't think so, because it's illegal. There were theories that Obama was going to try to run for a third term, but that was mostly just conspiracy theories because it's illegal. But if you could convince Congress to pass the law, then the problem is if it was an all Democratic Congress, it was even humanly possible. They could pass a law that says we will allow people to have 3 years, but it's half Republican and half Democrat, so therefore it would be pretty much impossible to get that passed. So anyway, probably. So anyway, I wonder what's on the futures market. Have you actually looked? Who's he lost some money? Was he betting on certain candidates that? Oh, he bought Rubio. Yeah, that would be a pure loss. So interesting. The people, yeah, it's kind of gambling, and it's gambling on the president. It's kind of a weird concept. Yep. But the cool thing is they do, like, it makes people put their money where their mouth is. Like, you know, who do you really think is gonna win? And then you don't even care if you're a Republican or a Democrat. It's like, who do you really think is going to win? And then you put money on it. And then if you win, you get money. So then you can, like, even if you're a Republican and you say, but I'm a Republican, but I think Hillary's going to win, you can still win, even if your candidate loses. So, interesting concept. Anyway, if you figure out exactly what site that is, if you want to Google that, tell me what site that is. I'm curious about that. Okay, so that is an example problem. And how did this 120 happen? Just to clarify, we stuck 20 for x and 20 for y into the profit function. Here's the profit function. 5,000 for each x plus 1,000 for each y. And if you stuck 20/20 in there, you get 100,000 for this part, and 20,000 for that part would be 120,000. That's how we got our max profit, which was to have 20 of each tree. That was assuming a whole bunch of constraints. You know, maybe in the real world, the profit is reversed. Maybe banana trees make you way more money than mango trees. I don't know the exact numbers. I can tell you mango trees are way bigger than banana trees, but I don't know exactly how much profit, of course, comes off each tree. Okay, so that's the process from beginning to end, including objective functions, including that feasible region that's all shaded in, and you can use your calculator for this test. That does not mean it's easy, of course. If you don't know what the two lines are that are crossing, graphing them isn't going to help you very much. You got to be able to write the equations, a lot of little parts. So this test that we have for a practice for you is, I would think of it that way. Think of this like a practice test, and it's worksheet. That's not it. I'm going to pause for a second while I find it. Found it here. All right. You know what? That is not it. Okay, so linear programming review, and the worksheet for that is right here. Of course, there's an answer key for it. you're really dumb if you don't check that answer key. For Pete's sakes, make sure you did it right. If you didn't do it right, take some time to figure out what you're doing wrong, because the test is tomorrow. 85% of your grades riding on it. This is your first test of the quarter. You want to start out right. Okay. And don't say, well, I'll come in tomorrow morning and get some help. Tomorrow's a Tuesday. It's not an option. You're doing this one on your own. So study for it. Check your answer key. And anyway, this one is very similar to the test. In fact, I like this one. There's some of these problems are just like word for word, just like what the test is. So bottom line, this is a great practice for what you'll see on the test. And it's not super long. So should be a fairly reasonable day. The test is not many problems, but the problems are kind of complicated. So it's a full-size test. It'll take you all hour. People usually do finish early, but okay. That's all I got for you for advice. Make sure you bring your calculator too. That's going to be handy. All right.